Hello, people. In this short video segment, I want to discuss the toolbar, which is called Measure, and specifically an icon called Measure Inertia in the Catia V5 program. When you click on the uh, icon on the right-hand side of the Measure toolbar, you get this depiction, and if you click on it, you'll get the dialog box shown on the right. Notice that there are two tabs here. The one on the right, which is specifically for 2D sections, and the one on the left, which is for 3D objects, 3D sections, which will be discussed in a separate video. Now, when it comes to the 2D section, it's a misnomer that we call it measure inertia, because when it comes to this particular tab, we are not actually calculating anything that has to do with inertia. We're actually calculating the second moment of area, and which is different from second moment of inertia in principle. But anyway, first thing that we need to do is to find out where to select the units for the inertia calculation or moment of inertia or the product of inertia. So if you go to the tools options and select the parameters and measure and the units tab, and you alphabetically sort it out by clicking on magnitude, you get a situation like this where there is inertia. Notice that the unit of it is millimeter to the, well, it's length to the 4, and inertia product, which is kilogram times length square or mass length square. So make sure that you select your appropriate unit. In this exercise, we're going to only worry about the inertia one, which has unit of length to the 4. This is for 2D, and the other one is 3D where mass is involved. But in the present tutorial, video tutorial, we're only going to be worried about uh, moment of area, basically, which is millimeter to the 4. Now, the help that's available in CATIA for this particular uh, functionality is fairly limited. It's kind of difficult to follow. Here is an example. When you click on the 2D section and then select a, a flat face or a flat surface, when you select that, you're going to get a dialog box like this. Now, ignore these numbers because these are just for sake of illustration. And if you click on the customize and you have already selected 2D tab, you click on this customize, you get the option which is fairly limited. A lot of these things are dim for the 2D section, okay? And these are fairly limited as far as what we can actually get, okay? Let's move on. As an example, I want to do this problem for you where I create a surface like that with that shape, and the using elementary calculus basically, the moment of area, second moment of area with respect to x-axis is given by this. Second moment of area with respect to the y-axis is given by that, and the uh, product of inertias, product term, product moment of area is given by that expression, okay? And of course, the location of the centroid is estimated as shown on the right. So what I have done, what I'm going to be doing for you is create this surface with these dimensions. So B is 1,000 millimeter, H is 500 millimeter, and C is 300 millimeter. And calculated Ix, Iy, and Ixy. This is all hand calculation. I want to show you the hand calculation to convince you that Catia comes up with the same answer. Okay, so the location of the centroid is of course given by these, and Ix, Iy, Ixy are calculated, and these are the values. So if you create a matrix Ix minus Ixy minus Ixy Iy, find its eigenvalues, you're going to get the principal values of inertia. okay, right there. Okay, and these are the principal directions. So I'm going to do this example based on these dimensions, and we're going to be checking against these numbers. We better get these numbers. Now, when you click on that surface, that triangle, with the right dimension, you're going to come up with different things. Here's the same, essentially the same MathCAD sheet. So notice that the hand calculation matches what Catia gives right there. And the principal inertials, these numbers match what you see over there. You will see that. And this is the directions, it's right there, principal directions. And finally, this is the inertia matrix that I in the principal direction. Notice that they match. Now, if you say, wait a minute, these are not quite the same, but notice that we're going from 10 to the plus 9 to 10 to the minus 6. So for all practical purposes, this is 0 and this is 0. Okay? And as a second example, I'm going to do this one and find the principal moment of area or principal inertials and the directions for a rectangle which is of this size, 1,000 millimeter sideways and 500 millimeter height. Now, by the way, these are coming from that PDF file from Arizona, University of Arizona. Okay, so you can find that in pretty much any strength of material or static / dynamics one. Okay, now the only thing is that when I do this one, I'm not going to create a surface. I create a box with that size as a section and then select the top face, for example, to get what I want. Okay, I better get these numbers. All right, let's go ahead to Catia right there. On the XY plane, I will sketch. This is in the XY plane. Notice that this is the XY plane. So I'm going to sketch my triangle. I don't have to dimension it. Okay, so this is going to be 1,000 millimeter. Okay, and this height from here to here is going to be 500 millimeter. Let me see what it was. Yeah, height is 500 millimeter. Very good. So that's going to be 500. What did I type? Yeah, 500. Let me move this thing over there. Now, this distance is 300 millimeter, or from here to that axis is 700 millimeter. So we go from here to here, 700 millimeter. That makes, this is 300, which is exactly what we had in the drawing. Now exit, because I want to create a surface here, I am in generative shape design, so I can do a fill here. It's going to put a surface there. Okay, so this is that triangle that I was showing you. Now, let me put it in the front view, maybe it's top view, top view. Okay, good. All right. So what you see there is actually this sideways. All right. Now here is the measure toolbar and there is the measure inertia. Click on it. Notice that there are two tabs here. This is for 3D, which we are not doing in this video. Select the 2D, this one, and select the fill, which automatically is going to select the part body. It doesn't matter. Select the fill. And notice what happens here is exactly what I showed you before. Now, first of all, the location of the centroid matches exactly what the hand calculation shows. Okay, and these are matching the hand calculation, and we get exactly what we expect. These are the principal moment, second moment of area, or principal inertials, misnomer. And these are the directions. These are the directions, which is right there. And this is the essentially the inertial tensor, okay, right there. That matrix, 2 by 2 matrix. Now, one thing you should notice is that when you do 2D section, these principal inertials show you if the axis selected is at the centroid, you can see that centroid is somewhere here. If it's in the centroid and aligned with these directions, then the product of inertia is almost zero, right there. It is zero, almost zero. And these two are going to give you the principal inertial values or principal second moment of area values. Good. So that takes care of this example. Everything matched. So now I'm going to do this one. Along x is 1,000 millimeters, and along height, in the height direction, we have 500 millimeters. So let's go back here. I'm going to start with another file. So start with another part file. I'm not going to do it here. All right. So on that horizontal axis, I will sketch. Just draw a rectangle. Now, just to convince you that location of it doesn't matter, I'm going to actually do a rectangle sideways, like that. And I'm going to dimension these things. So this is going to be 1,000. And this is going to be 500. Okay. So what you got is your sketch here. Now, of course, I can go and put a surface here, but I decided not to go that route. So I exit, and I want to make a volume here. Although volume can be made here, but I'd rather go to part design. You don't have to, we can create a volume here, but I'll go to part design, and then I just pad. The actual size of it, it doesn't matter. Okay, so let me make it, I don't know, 300, just to make it look better. There we go. So this top face is 500 by 1,000, 1,000 by 500. Now we're going to go to that measure. Click on that, measure inertia. Make sure you select the 2D tab and select that top face. And look at what happens. It identifies the centroid of that top face. It gives you the values of principal inertia right here, or principal moment of area of that face, 1.04 10 to the 10 and 4.1 10 to the 10, and those match these numbers right there. And the directions, of course, these directions are not 0, 1, 0, 1. If I had drawn this thing centered at the origin, I would have got direction 0, 1, 0, 1. But this is the orientation of these two lines, principal directions of the inertia or moment of area, and it's these things, these vectors, okay? But the important thing is right here and right there. Very good. So that takes care of this. In the next video, I'll be doing the other tab, which is a measure inertia in 3D. Good luck.